afternoon, everybody. How are you doing today? Good afternoon, everybody. How are you doing today? Can you hear me? How's my sound? Does it sound okay? Give me a quick sound check. Hi, Michaela. Good to see you. Fatima, good to see you. Wow, everybody I saw last night, it seems like. Hope everybody enjoyed lab last night. I think we had 20 people. Pretty good lab class. It was a lot of fun for me. I hope you enjoyed it. All right. Any questions? You folks seem kind of quiet today. Anybody want to talk? What you got to talk to me about? 5 people. Holy cow, 12:59. What do you think? El Yunque Forest. This is the rainforest in Puerto Rico, the only national park rainforest in the United States. It's an absolutely beautiful place with steep, lush mountains and amazing vistas over the Caribbean Ocean. Caribbean? So I highly suggest if you ever get a chance to do some hiking in the rainforest, you do. Uh-oh. Hmm. Okay. Everybody doing all right? Hello, Abbas. Fantastic. My CPU usage is a little bit high. Is my voice, am I lagging? Is the stream lagging? I have a feeling it is. Hmm. Okay. Okay, if you don't mind, I'm going to close down my program and come back in just a second, okay? So hold on. The live stream's going to disappear, but I'll be... All right. I'm back. Can everybody hear me now? For some reason, the CPU is really heating up today. Am I still jumping around, or is it a pretty good stream? Yes, I'm jumping around, you're saying. Or yes, it's a good stream. Ah, fantastic. Okay, yeah, I'm not sure. What's up with the stream today? I don't know. Oh, crap. And then the lights went off in the stinking room. Ugh. Here we go. Okay. Let's go ahead and get started. All right. All right. How's everybody doing today? Fantastic. Let's go ahead and get started. Hopefully this lecture won't last too long. Today we're going to talk a little bit about behavioral genetics and the use of twin studies to assess heritability and the heredity-environment correlations that make it difficult to figure out this heredity question. And then we're going to talk a little bit about epigenetics. So we're pretty much going to be talking about behavioral genetics today. It's great. I'm doing great. It's good to see you, Aria, Lorena. Good to see you folks. It was enjoyable talking to you last night. I hope you had a good time last night in lecture. I had a great time. You're a really smart, thoughtful group of people, which always makes my job a little more easy. You know, the more you talk and the more you know, the less I have to. I thought y'all did a great job. Wow, we got 10 people in here right now. That's a pretty good crowd. So Fatima, Araya, Lorena, Angelin, let's see, I forget who else is in here at this particular point, but it's good to see all of you. So we're going to talk a little bit about behavioral genetics today. You know what, this slide actually should have been put on yesterday's slide about infertility and reproductive technology. I'm not going to talk too much about it, but just know the definition of infertility, what in vitro fertilization is, and the fact that the mother's age does affect the likelihood of in vitro fertilization being successful. Okay, so one of the things that, oh, by the way, what do you think of my new classroom setup? Do you like this setup, or do you like the other one where I'm embedded in the PowerPoint? What do y'all prefer? If I could get a little feedback on that, I'll go ahead and get started though. So last Thursday, I didn't get to talk about it because the lecture crashed. But one of the issues that developmental psychologists are acutely interested in, is the question of nature versus nurture. Okay, great. Well, there you go. My introductory psych class liked it much better too. Even though I kind of like being in the PowerPoint and floating around, I seemed that I was always getting in the way. So I'll go with the light blue background and be up here saying, hi, folks. Okay. So one of the questions that developmental psychologists are interested in is the question of nature and nurture. So as we grow and develop over the course of the lifespan, how much of who we are is determined by the genes that we talked about yesterday, and how much of who we are is determined by the environmental forces that shape us. So part of your abilities to learn a language are genetically programmed. We are all programmed to learn a language, and that we must be exposed to a language within the first 3 years in order to develop that language ability. So you can think of that as the genetic aspect or the nature part of language. On the other hand, depending upon where you came from, you might have learned a different language than I did, and that might affect your development as well. So that's sort of the environment aspect of the equation. And what we're going to be interested in throughout the semester is to what degree are the changes and experiences that we're going through a product of our genes, and to what degree are they a product of our environment. Erica Schultz just dropped in and she said she can't text in the chat bar, so if she says anything, I'll share it with you on my cell phone. Okay? Now, behavioral genetics and behavioral geneticists are those people who are interested in discovering the influence of heredity and environment on individual differences in human traits, development, and behavior. So that's what behavioral genetics is all about. And what they're going to use is they're going to use two primary tools to do this. They're going to do twin studies and adoption studies. And the whole idea here is to look at similarity between people in different situations on given traits of interest. Okay? So for example, in a twin study, what they do is they look at the behavioral similarity of identical twins and compare them who share 100% genetic material, and compare them with siblings that only share 25% of their genetic material. And what you can do is you can see, do identical twins, are they more similar on traits of interest than are regular siblings or cousins or whatnot. And so that's a twin study gives us an idea of the degree to which a trait is caused by our genetic endowment. And then we'll compare that with adoption studies. So one way you could assess the impact of environment is you could get people together who are not genetically similar at all and see if they are more similar on traits than average people are. So if you think about it, my IQ is not going to be correlated with any of your IQs. We're all random and independent and have different experiences and different levels of intelligence. But what if you compared me and my stepbrothers on intelligence versus my correlation with people who I didn't live with? And if I am more similar to my stepbrothers than I am to people in general, then you might begin to guess that maybe my environment shapes my behavior a little bit. Okay? So, and one of the things we're going to be looking at is this idea of concordance rate. And concordance rate is simply a term we use to ask ourselves what percentage of the pairs that share the same trait of interest. So we might be looking at whether or not you're neurotic. And we might be interested in whether or not the concordance rate of having neurosis is higher for identical twins than it is for fraternal twins or siblings. Schizophrenia, the same thing. We might want to see how often pairs of identical twins have schizophrenia compared to how often siblings have schizophrenia. And so that gives us a way to assess the likely genetic impact that a given trait has. If the concordance rate is higher for identical twins than fraternal twins, and that difference is still higher than it is for maybe cousins, then we begin to guess that there is a genetic component to a given trait. And I know you folks probably in the popular media and news are all the time hearing about this trait, there's a genetic component, this is genetically determined, this is genetically determined, this is genetically determined. What they're talking about are behavioral genetics studies that look at the similarity that people have in their genetic material and compare it to their concordance rate. Am I making any sense right now? Hello, Erica. Glad to see you made it. Any questions? Is my screen jumping around still, or have I smoothed out a little bit? Okay. So, when you, let's talk a little bit about genes and chromosomes. So, goodness me, hold on real quick before I go saying something stupid. Hold on. Do 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 do. Okay, so oh crap, hold on just a second. Okay, so all right, what I wanted to say was you were doing amazing. Okay, fantastic. You smoothed out. Of course I'm smooth. All right, so a zygote is a fertilized egg cell. So a zygote occurs when your two gametes, your mom's ova and your dad's sperm, get together, and that gives you your supply of genetic material. Now, the thing is, you get half of what you've got from your mom and half of your genes from your dad. So, in a sense, you're 50% genetically similar to your mom and to your dad. Now, an identical twin occurs when one sex cell, one zygote, splits into two. All right. So after an ovum has been fertilized, it splits into two distinct human beings that share 100% of the exact genetic material. So identical twins are more genetically similar than are children and parents. You share 50% of your genetic material with your parents, 100% with your identical twins. And it turns out that you share about 25% of your genetic material with your regular siblings, or with fraternal, or what we call dizygotic twins. So there are two kinds of twins. There's the twins that happens when a zygote divides after being fertilized, and those two twins are identical. They're 100% genetically similar. But sometimes what happens is the mom releases two eggs during the same cycle, and they are fertilized by two sperm cells. Now they grow in the mom's uterus at the same time, and when they're born, we call them twins, but they're what we call fraternal or dizygotic twins. And really, they're just brothers and sisters who happen to be sharing the same uterus, right? They're sharing womb service for 9 months. Is my image shaking any? I'm getting a message over here that my image is getting a little shaky. I hope that's not the case. All right, so here's the way you can think about it. You are 100% genetically similar with your identical twins. You are 50% genetically similar with your parents. And you are 25% genetically similar with your siblings who aren't identical twins. And you're 0% genetically similar to me or anybody else that you might run into on the street. So in a sense, what you can do is you can look at these genetic differences and look for differences in concordance rates. Okay? Now, there are lots of ways, and over the course of this semester, we're going to come back to this, and we're going to talk about behavioral genetic studies. And when I say stuff like this trait is genetically determined, and I show you a chart that looks just like this, what I want you to know is that these results probably came from a behavioral genetic studies, because that's how we establish these genetic components. All right. Now, what are the human qualities that show a genetic component? Personality shows a genetic component. If your parents are shy, you're more likely to be shy. Intelligence shares a genetic component. If your parents are intelligent, you're likely to be intelligent. And you know what? A lot of forms of mental illness or psychological disorders do have a genetic component. If your parents are schizophrenic, you're more likely to be schizophrenic. If your parents have an anxiety disorder, you're more likely to have an anxiety disorder. Now, there are some psych disorders that do not show a genetic component, but behavioral genetics typically show that most psychological disorders do have some sort of genetic component associated with them. And so what I want you to see right here is this chart that looks at personality traits, the influence of genes on three personality traits: your happiness, your negative emotions, so think of it as your neurosis, your anger and anxiety. So your happiness, your anger and anxiety, and constraint is your self-control, your ability to do what you are supposed to do rather than what you want to do. And what you can see here is that each one of these personality traits shows a much higher correlation for identical twins than for dizygotic twins or adopted siblings, step brothers and sisters. So if you look at this chart, you can clearly see that there is something genetic about personality. Now, I'm going to talk about this. I talk about this in my personality class, but just to give you an interesting note here, it turns out that identical twins who are reared apart are more similar for personality than identical twins who live in the same house. Identical twins who grow up together are more similar in personality as adults than they are as children. Does anybody have a theory why that might be true? It actually suggests that personality is more highly correlated for identical twins that don't live together. Why? I'd be interested in hearing your theory. Hopefully somebody will type me a brilliant theory up here. But we'll talk about it. Now, the thing is, are genes everything? No. You'll notice right here that the correlation for positive emotionality with identical twins is 0.53, which is a super duper strong correlation, but that is not all of the variance. There is some variation. And so one of the things we like to think about, two terms that we think about are what we call canalization and reaction range. And you know what? I probably I didn't write these down, so let me go to the whiteboard real quick. Okay, so canalization. the degree to which a trait is determined by genes. Right? So if you think about it, eye color, all genes. So you might call that highly canalized. The root here is canal. Think of a canal as a ditch, right? And personality is less highly canalized. That means that you're identical twins. You can be genetically similar as identical twins, but this person, the environment may shape their trait a little bit. There's no way I can tell you dirty jokes and turn your eyes blue or green, right? They are what they are. So you can't really change that. So we talk about canalization, and then another term that we talk about is called reaction range. And then this is the variation possible around a genetic set point, right? So let's see, this is Timmy, and Timmy is born with a genetic IQ of 115. Now, if his parents really give him the best environment they possibly can, take him to all the schools and all the summer camps, his IQ might move up as high as 120. On the other hand, if Timmy grows up in an environment where he's neglected and abused, his IQ might only be 110. So you can think of this variation about his genetic set point as his reaction range. And so this answers the question, can you change somebody's intellect to a certain degree, but not totally? So this right here is Freddie. Freddie's genetic set point is 85, right? Okay? Now, if I put him in the awesome camps and all these great educational activities, his IQ may still only get up to 90. On the other hand, if we abuse and don't pay attention to him, his IQ may only get to 80. This is his reaction range. So in a sense, you can see genes and the environment at work right here. So you've got a genetic set point, and then you've got a reaction range about that set point by which the environment can affect that genetic trait. And remember, traits that are more highly canalized do not allow for you to move them very much, right? So you can't really change my eye color, but you can change to a certain degree maybe personality traits or intellectual functioning. I think when they're a kid, they're developing personality so much, they live together, they don't act that much, but they're the same. The adults, the nature they brought. Ooh, Angeline, can I give you a virtual high five? She is right on the money. Environment works too, because you are two twins trying to distinguish yourself as kids. So you probably are shaped by your environment to differentiate yourself from your twin. Now, if you don't live with them as a kid, then you don't have that power and you go to your nature. As an adult, you revert back to that nature. So Angeline, you hit the nail on the head. Very, 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 very good guess there. I like that. Does everybody understand the terms of canalization and reaction range, and how we have a genetic set point, but then we can vary about that set point based on our environment? I hope that makes sense. Okay. So here's the thing. What makes it difficult, though, is a lot of times our environment works in the same way to kind of help shape the abilities that we have genetic predispositions for. And so when you start asking the question, is it environment or is it genes, you have to take into the fact that the environment often supports the genetic endowment. So what I'm going to do is give you some examples of what we call heredity-environment correlations where they line up and work with one another. And I'm going to give you examples based on my experience, okay, just so you can sort of see how it works, at least for me. And you can think about how it might work for you. So there's the passive gene-environment correlations. You know what? You may have a genetic endowment, but your parents have the same genetic endowment. So the things that they find interesting and that they're good at, they're going to keep around the house because that's what they like. And so you're going to find yourself in an environment that supports your genetic predisposition. So in a sense, it's going to magnify that already existent genetic trait. For example, my mom was a very good reader, and she loved to read. And there were books all over the house, and so you know what? I like to read too, and there were always cool books to read about. And so I don't know if any of you have heard of that movie Donnie Brasco. It was made about 10 or 15 years ago. You know what? That book came out in the mid-70s. I read it as a 9-year-old, right? Just because I was always reading books. So the environment just happened to passively support my genetic predisposition towards reading. Okay? Does that make sense? Now, there's also the evocative heredity-environment correlation. You may engage in a particular behavior which causes your environment to change in such a way that it encourages that genetic endowment. All right? So here's the deal. My parents found out that I liked puzzles when I was 8-year-old. Word crosses, logic puzzles, all those different kinds of logical things. And so as soon as they found that out, you know what my parents started doing? Every time they went to a store, they bought another puzzle book. Because I showed an interest in puzzles, my parents created an environment that would help that puzzle doing ability grow. So my initial tendency evoked an environmental response that then magnified that genetic ability. All right? And then you know what? Children, sometimes the organism on its own will find environments that reinforce its desired behaviors. So if you like sports, you will gravitate to the basketball court when you have free time on your hands. For me, when I had free time on my hands, I would gravitate towards the library and be a nerd reading books. This was the 70s before we had the internet. You had to read these things called books. I don't know if you folks have ever heard of them before. But sometimes a genetic predisposition will cause you to pick an environment. Now, the reason I tell you about all of these is because these environment heredity correlations kind of muddy the water as we try to figure out whether or not a behavior is truly genetic or driven to some degree by the environment. Okay, now really I want to end by suggesting to you that the modern view is what we would call the epigenetic view. And what these people argue is that we have genetic predispositions, and the environment can actually affect our genetic expression. So you may have a gene, but that gene is not expressed unless a certain situation occurs, or a certain situation, abuse or poisoning or some sort of chemical may actually stop the expression of a gene. So you have a genetic endowment, but sometimes environmental conditions can turn genes on and off. And so what you think about these effects that turn genes on and off, you can think of them as epigenetic mechanisms. So there are people who have genes that are related to anxiety. And it turns out that whether or not these people develop anxiety and depression depends upon the environment in which they're brought up in. These genes don't express themselves and affect our cortisol functioning unless we're in a stressful environment. So you may have the gene to be schizophrenic. You may have the gene to be, actually, you know what, and this really sort of raises its head in the onset of mental illness, because we know there's a huge genetic component for schizophrenia. And if there is, why don't people express schizophrenia when they're born? Why does it wait until your late teens or early 20s to occur? The idea is that you have the gene, but the gene, in order for it to express itself, it needs a certain sort of environmental stimulation. Does that make sense? I'm not getting as much feedback today as I usually get, and so I'm just hoping that I'm making some sense here. Any questions? Any questions? Okay, today's lecture was actually quite short. Last semester I tried to stick chapters 2 and 3 together in the same week, and it was a little bit crowded. So this semester I decided to do chapter 3 separately from chapter 2. So this week is actually a couple of minutes short. All right. If you don't have any questions for me, I'm done. I do want to remind you, do the discussion board to get the extra credit if you didn't come to a webinar. Actually, I think 20 out of 28, so almost all of you come to the webinar, which is freaking awesome. But if you did come to the webinar and you want the extra credit, please go do the discussion board before tomorrow night at 11:59. Well, thank you very much, Lorena. It's really nice meeting. It was nice meeting you and having you talk in class last night. That was super awesome. Fatima, good to see you. Good to see you. All right, good deal. Well, you know what? I am going to log off here. But if you need me, I'm available via cell phone. You can text me or send me an email. Otherwise, I'm going to be working on preparing next week's chapter for you. Take care and have a great day.